So this is a screencast for Topcoder SRM 590 Division 1. So the 250 problem, I'm looking up the problem statement right now. We have someone playing a game with some chess pawns and a strip of paper. The strip of paper is divided into a row of cells. Each cell can contain at most one pawn. Okay, so the white pawns will be denoted by R because they're only allowed to move to the right, and the black pawns are denoted with L because they're only allowed to move left. You're given a string begin that describes the current state of the strip. So R and L are cells with corresponding pawns, and a dot is an empty cell. Okay, so you're now allowed to make some moves, as many as you wish, possibly 0. In each move you either take an R pawn and move it to one cell to the right, or take an L pawn and move it one cell to the left. Of course, both types of moves are only valid if the destination cell is currently empty. Fair enough. Pawns are not allowed to move out of bounds. So you're also given a string target that represents the desired state of the strip. If it is possible to reach target from begin by making valid moves, return possible. Quotes for clarity. Otherwise, return impossible. Alright, so what am I trying to do here? So I have a vector of pairs where the first guy is a character, the second one is an integer. So one for player 1 and another one for player 2. So I iterate through. If begin at I is not, so if it's non-empty, if it has either an R or an L, I push it to this P1 vector, and I push the character and the index. Okay, I do the same for target. So okay, so I check. So I'm writing code comments. I wrote check same order. Okay, so that means that the guy, okay, what does that mean? So P1 has, okay, first we check, okay, the two sizes have to be the same. Well, yeah, of course they have to, because otherwise it's impossible to get more pawns into the board, because that's not a valid operation. So what is same order? Same order what does it mean? Oh, when you move the pawns, you cannot go over a pawn. Like, you cannot jump over any other pawns. So in your begin and target, you must have the same pawns in relative order to each other. So that's what the check same order comment means. Yeah, so that makes sense to me right now. So what about check indices? So now that we have determined that they're all relative in order, now can I move? I think that's what the next thing I'm doing. Can my pawn move to that place which I'm checking the indices? Okay, so if pi.first is equal to R, so it's I think that it's one of the pawns that moves to the right. So if it's one of the pawns that moves to the right, I need to make sure that the index on P2I is greater than the index at P1I. Why? Because I cannot go to the left, right? I can only go forwards to that one position. So if my target position is to the left of my pawn, then it's impossible, and that's what we have in here. So else my pawn is one of the L pawns, so my pawn can move to the left. I need to make sure that my target place is to the left of my pawn, because if it's not left, I cannot get to it, so it's impossible to get there. So at this point, I'm pretty sure I was convinced that my answer was correct. So at some point I will submit here. Maybe I don't think I was so convinced at this point, because it looked really easy, and this is the type of problem I'm really good at for some reason, like simulation. I'm really good at it. So I guess I'm just thinking at this point before committing to the next problem, which is I'll find the problem statement, read it to you. I was not able to solve it, but I got some work on it. I did some work on it, basically. So you have a set of cards. There is one non-negative integer on each card. Different cards may contain the same integer. For each I, the number written on the ith card, zero-based index, is number I. So your friend wants to select a subset of those cards such that the bitwise XOR of the selected cards is less than or equal to limit. So you're given a vector number and a long limit. So count the number of ways in which your friend can select a subset of cards. Two subsets counts as different if they differ as sets of cards. Okay. So at this point I'm still double checking my answer because it looked too easy. Yeah, like sometimes they look too easy and you think you've made a mistake, but you haven't. But it's always better to check now than to check later, because if you find out later during the match that your solution was wrong, you just lost a bunch of time, and if you need to resubmit, you'll get really a very low amount of points. So it's always optimal to check if your solution is correct right after you submit it. Okay, this one, the 500 problem, I've never solved one of them. So I usually just go for the 250 in division 1. But I think, but I don't remember the code I wrote, because I did this SRM like a while ago, and I'm just looking back at them to add some commentary to be able to upload this to YouTube. So I don't know what I attempted on the 500 problem yet. We'll have to wait for old me to finish testing this the 250 problem. So yeah, what I did on the 500 problem was to just brute force everything. No clever, because I did not have the solution. Usually you need something very clever. Yeah, so the problem is the 500 problem. You have some cards, you want to select a subset of those cards such that the XOR of all of them is less than some limit. And you want to count the number of ways that is possible. So let's see what I tried here. Yeah, I think I solved this problem, but it was really slow, so I did not submit it. So I had a map that takes a long and returns a long, but what was it for? Oh yeah, I think I brute forced this one in a way such that in the map M, I mapped all numbers to it, and I counted the number of ways it occurred, like this thing happened. And so right at the end, I would iterate through this map, and I would check if the key was less than the limit, and if it was, then I added like for a total, I added the number of ways to get to that number. So yeah, I just have 2 for loops. One to go through the first number, then to the second number. I did the XOR, updated my map, because I at some point I have another map, like a temporary map. And then I just accumulate everything over M. I mean, it works, but it's not efficient. I don't think I read the editorial for this one. I don't remember. So I'm not. So my commentary will end here because I have nothing else to add. So if you want to keep watching, feel free to do so. If you know how to solve this problem, post your algorithm in the comment section below. I'll read it and try to maybe implement it or something, because I really need to get better at the 500 problems, because I've never been able to solve one, and that's probably the next step. But maybe I should also improve my time, my speed on the 250 problems. And yeah, so if you know the solution, post it in the comments. I would really appreciate it. Thanks.